Okay, solve problem F16-17. The angular velocity of link BC and the velocity of piston C at the instant shown. So this wheel has a angular velocity of 6 radians per second, which is going to drive point B to the left at a velocity of omega times r, which is 1.2 meters per second. And then that will pull this rod down, constrained to that slot, VC, in the direction of 30 degrees from the horizontal. Now, using the method of instantaneous center of zero velocity, we draw, since these are non-parallel lines, we draw the perpendicular angle from each of the two. And where those two perpendicular lines meet is the instantaneous center of zero velocity. Now, this rod rotates around that center. So the velocity of any point on that rod is perpendicular to the IC, as it is on the ends. So you can use the V equals omega r also to find omega. So V is 1.2. Omega, we don't know. R, we can find, because this is a right triangle. This is 0.8, and this is also 30 degrees. So if that's 30, this is 60. And the tangent of 60 will equal the y value there over the x value here, which is 0.8. So y is equal to 1.39. 1.39. Therefore, going back to our V equals omega r, 1.2 equals omega times r of 1.39. So omega equals 1.2 divided by 1.39, which is 0.863. Okay, now to find the velocity c, we can use v equals ir again, but we need to know this distance. Now this is 0.8, this is 1.39. So using a Pythagorean's theorem, we can find the square root of 0.8 squared plus 1.39 squared is equal to 1.6. Therefore, this distance is 1.6, and so V equals IR, or omega r. So the velocity at C is equal to omega 0.863 times r, 1.6, and VC is equal to 1.38 meters per second, and it's at 30 degrees from the horizontal, so it'll have a negative I and a negative J.